Yeah, we have been supporting through CII actually.
Yeah.
So not directly from DST.
Does the government know you have the program?
Yeah. So through this global
Well, you
innovation
should. I
technology.
mean, this is something
Yeah.
that
So how
if
to
you have a
contact?
program,
Yeah. How to
nothing like it.
contact you? Because
Nothing like
I would
it.
like to take this PPT copy and then discuss within
I
department.
think you should. I think you
And
should
then we'll
involve
try to
some of the
move
scientific
forward on that
academies.
one.
You know, you should involve not only INSA, but you should also involve the National Academy of Agricultural Sciences. You know.
I think it could be done at many
yeah,
levels
yeah,
without
please.
involving the government. University to university is the simplest. The next simplest, but it's much more complicated, in my opinion, is the two Academy of Sciences. Okay. And I'm happy to do either one.
My question is related to the projections of rise in temperature. I'm R day, Rajarshi day, rise in temperature and sea levels. If you say that the temperature will go up in a century, by end of the century by 3 to 4 degrees, one can assume that the temperature will increase to 30 to 40 degrees centigrade in 1,000 years. I don't think any human being or plant can survive that kind of temperature, extreme temperature. Now, and so far as sea level is concerned, if the sea level rises by 60 meters in 1,000 years, which coastal area will remain intact? All these urban areas, cities which are located near the sea, they will be submerged. So there has to be some future planning to save these areas. And do you agree with my suggestion that it is very destructive and catastrophic if these temperatures and sea levels projections are correct?
Yeah, I think we all hope that that won't happen. I worry about civilization collapsing as a real thing. That once you pass a certain tipping point, it will become so expensive to remediate it that economies will collapse, there will be mass migrations, there will be wars over diminishing resources, and civilization will collapse. That's enough of a catastrophe for me. I think some humans will survive, but they will be, their culture will have disappeared. That to a scientist, is a disaster, I think, to an artist, to anybody who cares about what humans have accomplished as a civilization should worry about that. I think that's immediate, decades kind of time scale. We'll know whether that's a real threat or not. I see very little way out of it if we go as business as usual.
Professor, let me ask you a question. Your first slide, where you talked about thorium, you started off with the Bhabha slide. Now, where does your thorium model fit into the three-phase program of Bhabha?
Third phase.
It's in the third phase.
Yeah.
So you have to, the fast breeder is an essential.
No, we can get rid of the fast breeder.
That's the question I wanted to ask you.
Yes.
Do you get rid of the fast breeder in
Yes.
your solution?
Yes. Because the same reactor design can convert essentially plutonium, the neutrons in plutonium.
Well, as you know, we are now in the second phase.
Yes.
We are, our fast breeder is 98% ready and probably be commissioned in the next 8 to 9 months. So we'll have the first of the 500 megawatt fast breeder. And the idea is that we have a family of 4 or 5, and then we make the transition to the thorium reactor.
Right.
That's going to take us another 20 years. We've been waiting for thorium for the last 50 years. We probably will end up waiting for another 50 years. So that's my question was that do you bypass the second stage and go directly into the third stage?
Right.
You don't have to go through the sequential process.
There's a catch. I think the problem, why the fast breeder was needed, is because India does not have enough nuclear waste. Okay, it's a resource, you don't have enough of it. So, my proposal is somewhat political, and I have no control on this. I think there are plenty of countries that will give you their spent fuel if you say you'll process it for them, take it.
It's very difficult now, after 60 years, to abandon the three-phase program.
Well, so it could be a backup.
So it has to be a
But-
parallel program.
Right. But I would just mention this. Many countries have tried to breed fast breeders. They've never bred. They've always ended up being essentially burners.
Yeah, I know.
They
Yeah,
burn more
at
than
the end.
they
Yeah,
make.
please. Sorry. Okay. Yeah. Another 10 minutes? 10, 15 minutes? 5 minutes.
Salt technology applicable to all conditions, because every technology has some loopholes and drawbacks. I think it is applicable to only thorium dominated countries. What about the countries where thorium is deficit? Could you explain?
Well, so the molten salt reactor is a proven concept, but they did not use thorium. It was too complicated. However, the first reactor that was ever built was a shipping port, at Shippingport, which is a converted nuclear submarine reactor. And the last experiment they did was to see whether thorium breeding was possible. And they found it was possible using light water technology. You have to be really, really careful to get that, breed more fuel than you burn. They were able to do it by just being careful. With thorium and carbon technology, it's much cleaner technology. So I have no fear that it's impossible, it's theoretically impossible or practically impossible. I think you can do it. There are some difficult points, and we discussed them at the BARC, but nobody could find a showstopper. In fact, after the meeting was done, the chairman of the BARC said, well, if you took a poll of the people in the working there, probably 90% of them would say molten salt reactor, thorium molten salt reactors are the way to go. Now, other thing I would mention is that is China's top reactor. Okay? That's their top priority. They're nowhere as good as India in this field. You've been thinking about it much longer. There's all sorts of chemical things that you need to do, materials issues, corrosion issues. Your people have thought about this. So you're in the best position. If India doesn't build it, I don't know who will. Okay? China's trying hard. They have a budget that's 100 times what I had in Taiwan. All right?
Any other question? Yeah, I think we have two. Any others? Three. Yeah, let's give the lady. Yeah, please go ahead. Professor, why don't you take the 4 questions together, if you don't mind, so that we can compress it. Yeah.
This technology is being used by how many countries? You said China is trying very hard. And how many other countries are using it?
Yeah, next one. Yeah, go ahead. Just speak a little louder into the mic.
India has an abundance of the sun. Why do we use India has an abundance of the sun. Instead of nuclear fuels, why don't we use concentrated solar thermal with molten salt as an option?
Not cheap. California has built such a thing. It's very expensive. It's near where I live. Okay. It's true that India has a lot of sun, but you also have many days when there's no sun. And so you would have to overbuild to be able to use the sun in a large way. No, people have studied this problem. There's never been a demonstration anywhere that you could use more than the solar power, more than 30% of your energy needs. Never. If you use batteries to store it, batteries are some of the worst technologies in terms of bad for the environment. So molten salt storage is a good idea, but it's expensive. Okay.
Supertorification and biochemical. Sorry.
Oh, let's see. Your question was
How many countries?
using molten salt in which way? Biomass or? Biomass and nuclear.
Your technology, what you outlined right now, how many countries are actually using? It's very depressing that we've only got 30 harvests left, the 30 years left.
Oh, yes.
Yeah, what Mr. Jairam Ramesh said,
Yes.
that you brought us really
So,
down. So
relative-
if more people are going to use this technology, hopefully we can have many more harvests.
Yeah.
So
Well,
how many are
this
adopting
technology
it?
has been in existence only for the last couple of years. And we've done demonstrations for a lot of people in Taiwan. The Minister of Agriculture came, said it was great, but he has no money. EPA person said it was great, but he has no money. So finally I said, look, I'll pay for it. I'll put my personal money into it because I don't want, other people putting money into a risky thing. We'll demonstrate that it's possible to make money. Then I hope the government will come in and do it. So I put my own money into it, okay? I formed a company. I'm building a plant in Hsinchu County, all right? And we have agreement with the government, the county government, who also tells me, the county magistrate, we have no money. I said, fine, we'll do it, okay? It's not so expensive, that a private person can't do it.
It sounds very energy intensive.
Pardon?
It sounds very energy intensive with high heat and high pressure.
No.
No?
As I said, you can burn of order 10% of what you make, and it would supply the heat. So that's a charcoal fines thing. We have direct measurements. You put it in, come and look. You see the temperature rise, okay? We know exactly
I think you need to look at the energy balance because most solutions I have seen, you end up spending more energy than you're getting out of the end. I mean, biofuels is a classic example. So I think the point that she has raised is an important point. And when you do your scientific exercise, I think energy balance should be one of the fundamental prerequisites. I think we'll take the last question.
Purification
last
and
question.
biocarbon, what means to you? Simple 2 words only. Super purification and biocarbon. What means to you?
What's the issue?
What means to you? Don't know.
What is he asking?
Super purification. Super purification. Chloritorification. Super tori. TRRO.
Torrefaction is a word.
And biocarbon.
It's used to make
Different
coffee. For example, when you roast coffee beans, it's called torrefaction. People making charcoal with steam, or the old-fashioned way, just burning part of it, called torrefaction. Torrefaction is typically the highest temperature is reached is about 280 C. You're doing it with gases, so it's very slow because the temperature is low, and you're doing it with gases. We're doing it with a liquid at higher temperatures, so it goes much faster. That's why we call it super torrefaction. At even higher temperatures, but it becomes very corrosive, it's called pyrolysis. You could do it in principle in seconds. Okay.
I think we have come to the end of the evening. You can have any questions, you can take him. I want to thank the professor for a very fascinating lecture. I was bowled over by your title. It was Reversing Climate Change. So I came, that's why I started off by talking about geoengineering, which is really reversing. You're not talking of reversing climate change. You're really talking about moderating the rate of increase in the CO2 ppms through the use of technologies like nuclear, thorium, and so on. But I think it's